Have you ever stopped to think about how truly amazing it is to send a message? You tap a few buttons on your phone and poof! Your friend across the country, or even across the world, sees it almost instantly. It's like magic, right? Well, it's not magic. It's science. Every time you stream a video, send an email, or make a simple phone call, you are sending tiny bits of information on an epic journey. That journey involves super-fast highways, invisible waves, and traffic rules that keep everything moving smoothly. It's a complex dance of physics and engineering happening millions of times every second. A message from you to a friend is like a letter you want to send. Instead of a truck or mail carrier, the letter breaks into tiny pieces and races along special pathways. They might travel through a wire under your street, bounce off a satellite high above Earth, or zip through the air as radio waves. It all happens on a microscopic scale, in the blink of an eye. The world is more connected than ever before. We can talk across continents and access a global library from our pocket, all thanks to the systems that let our messages, pictures, and videos travel. They are the roads, bridges, and tunnels of the information superhighway. We're going to dive deep into what these pathways are made of and how they work. We'll peel back the layers and see the machinery that makes it all tick. We'll look at the physical stuff that carries our data and the rules that govern its flow. We'll keep it simple with fun examples. By the end, you'll see your phone, computer, and Wi-Fi router in a whole new light. You'll understand the science behind the screen. Let's go! The world of data transmission is truly cool. Billions of people are connected by this science. All right, let's get down to basics. What is this transmission media stuff anyway? Imagine you want to talk to your friend across a big field. How do you get your voice to them? You could shout. The air carries sound waves. In that case, the air is the medium, the physical path your message travels. Transmission media in tech is the same, the path our emails, videos, and voice calls take from sender to receiver. It's the road, the track, the airway. Think of it like plumbing for data. When you turn a faucet, water flows through pipes. The pipes are the medium. Similarly, when you send a text, data flows through a transmission medium to the other phone. It might be a cable plugged into your wall or invisible Wi-Fi waves. Anything that carries a signal from A to B can be a medium. It's the fundamental component that makes communication from two cans and a string to the global internet possible. It's the bridge that connects us. Transmission media are carriers of information. They don't create it, but they are essential for moving it. Without them, your computer would be an island. Your phone couldn't call or access the internet. It's the physical substance, copper wire, glass fiber, or the air around us that carries signals. The unsung hero working behind the scenes. There are two main families, wired or guided media, like your TV or telephone cables, and wireless or unguided media, like radio and microwaves. Both have different strengths and uses, but they do the same job. Give our data a path to travel. Let's take a closer look at these two families. Let's start with what we can see, wired media. These are protected highways and tunnels for our data. Common types include twisted pair, coaxial, and fiber optic cables. Twisted pair, several copper pairs twisted together. Twisting cancels electrical noise, keeping calls and internet clear. Coaxial, a central copper wire, insulation, metal shield, and outer cover, like armor that blocks interference for longer distances and more capacity. Great for delivering hundreds of TV channels. Fiber is the champion. Instead of electricity, it uses light pulses through thin glass strands, thinner than a human hair, moving huge amounts of data with little loss. A single fiber can carry more than a bundle of copper, making it the backbone of the global internet. Buried under oceans, beneath streets, and inside data centers, these hidden superhighways form the skeleton of our digital world. Without them, the internet as we know it wouldn't exist. Now the invisible side, wireless media, where data travels through open space without cables. We use electromagnetic waves, radio waves, microwaves, and infrared. Your Wi-Fi router, cell phone, car radio, and TV remote are constantly broadcasting and catching signals in the air around us. Radio waves can travel far and pass through walls. That's why Wi-Fi works in the next room. Microwaves are higher frequency radio waves. Your phone uses them to reach the nearest tower. Towers pass focused beams to other towers in line-of-sight chains. For the longest haul, we beam up to satellites that bounce signals back down. How live international news and calls cross oceans. Infrared is great for short-range line-of-sight control, like your TV remote, and doesn't go through walls so you won't change your neighbor's channel. Wireless gives freedom and mobility, staying connected in cafes, cars, or on the go. We have our pathways, wired and wireless, but how do ones and zeros ride them? It's all about modulation. A smooth carrier wave is like blank paper. We alter it in patterned ways to write data. Make the hum louder or softer, raise or lower the pitch. These variations represent data. The receiver listens and decodes them back into the message. In copper wires, we modulate electrical voltage. Higher might be a 1, lower a 0. Rapid changes stream data. The receiver samples them thousands or millions of times per second. Reassembled into a file, a web page, or a voice call, like a light switch code, but incredibly fast. In fiber, a laser flickers on and off. Light pulse for 1, absence for 0. A detector converts flicker back to electrical bits, faster than voltage can toggle, so fiber carries far more data. For wireless, think radio. A station transmits a carrier, then modulates it. In FM, frequency shifts with sound. In AM, amplitude changes. Your radio detects tiny changes and plays the audio. Wi-Fi and cellular use complex digital modulation, but the core idea is the same. Change a wave to encode information. Now that we know how data travels along a medium, let's talk about the rules of the road, transmission modes, and the direction of data flow. The simplest mode is simplex, a one-way street. Data travels from sender to receiver only, like radio or TV broadcasting. Your radio receives, but can't talk back to the station. A keyboard is another example. It sends to your computer. The main data path doesn't send back. Status lights are separate. Next, half-duplex. Data can go both ways, but not at the same time. Like a single-lane bridge, traffic alternates. Classic example, walkie-talkies. Hold to speak while the other listens. Release and say over to switch. Devices coordinate to avoid collisions. One channel handles both send and receive. Efficient and cost-effective, but turn-based. Finally, full duplex. Two-way communication at the same time. A phone call lets both people talk and listen simultaneously, natural and seamless. There are two simultaneous paths, one for your voice, one for theirs. Modern Ethernet uses separate wire pairs for sending and receiving, so you can upload a file while streaming video, no waiting, boosting overall speed. Full duplex is the gold standard for interactive communication, why video calls feel responsive and games feel snappy. Knowing media and modes makes you a smarter technology user. If Wi-Fi is slow, think interference or too many devices sharing a half-duplex channel. A wired full-duplex Ethernet connection is often faster and more reliable for gaming. Comparing plans. Fiber means super-fast light pulses, often with fast uploads and downloads, while cable and DSL differ in speed and symmetry. Media and modes shape economies. Undersea fiber unites markets. Cellular full duplex brings communication to remote areas.